Welcome to the third and final video tutorial in our Gliderscope series. In this tutorial, we'll get to the fun part. You will learn to plot and visualize the full range of glider data, including water temperature, salinity, fluorescence, and other parameters. This series of video tutorials are designed to be used alongside of our publication, Observing the Oceans with Gliders, Techniques for Data Visualization and Analysis, published in the journal Oceanography. Follow this link to access our paper. By now you should have downloaded Gliderscope and the sample data file. If not, go to our website here and catch up. So let's get started. With Gliderscope open, load the sample data .netcdf file that you previously downloaded in the last tutorial. Gliderscope's telling me what to do here in the green window, so I'd better do as I'm told. There's the file. And there, in the top plot, is the entire track of the glider's mission. Let's select the first outward transect of the glider as it goes offshore by using the mouse clicks. Firstly, let's split the data. On the right plot, let's use mouse clicks to select from the very start of the mission to the end of the first offshore transect. And this is the data we're going to pass to the plotting window by pressing Done. Well, hello plotter. Thank you for your kind offer. But firstly though, there are several ways you can plot your data, and I'm going to show you an example of each of those. Let's try plotting time series first. These plots are particularly useful at looking at how seawater properties can evolve over time. I'm going to choose temperature, press display. This gives you a preview, and if you're happy, press plot. Now, try this again, but this time select salinity, for example. Display again and plot. Now, you can start lining up these plots and really having a good close look at your water body. But for now, we're going to remove these plots and move on to color-coded data points. So let's try, but wait, a warning first. If you want to plot in 3D, and let's face it, everyone does, only plot a small section of the mission, as this will take time to compute. Using this option, glider data are shown as color-coded points spatially positioned where they were taken. Now, this type of plot is especially useful for analysing vertical transects of the ocean at specific points. Let's pick temperature again in 2D. Display it first, and then let's plot. You can also produce contoured cross sections where the data is interpolated between measurements. Let's do this with temperature, and you can produce a plot with a color bar or with labeled contours, and you can change the interval of the contours. Display this and plot the contour plot. Want to compare water properties? No worries, you can easily compare properties such as salinity and temperature to identify different water masses. Finally, Gliderscope allows you to plot depth profiles of variables together, and this is handy for locating thermoclines, pycnoclines, and chlorophyll A max. In our case, let's just plot temperature and fluorescence together. It's important to remember that data from each plot can be extracted and saved into text files using the Save Data button at the bottom of each control panel. At any time, if you want to select a different section of the flight path or load up a totally different data file, press the Go Back button, and if you wish to end Gliderscope, press Quit. Thanks for joining me in this series of tutorials. We have really only scratched the surface of Gliderscope, but you have probably heard enough from me for now. I now recommend that you use our publication to fully explore Gliderscope on your own. You'll love the versatility and have some fun along the way. Good luck on becoming a glider data scientist.